Hello. So the next thing in volumes of revolution is about adding and subtracting volumes of compound shapes, essentially. So firstly, recall that the volume of a cylinder is given by pi r squared h, and the volume of a cone by a third pi r squared h. And as we sort of mentioned before, the way to prove these, well, I think we've seen the way to prove these is essentially using the volumes of revolution formula using calculus. Well, for a cylinder, you can also just obviously take the cross section and then multiply by the height because it's a prism. But for a cone, we can use what we did in a previous video to show this is the volume. But these two formulas are going to be useful in this section because sometimes we have an example where we have a shape that's made up of straight lines, and then we need to add or subtract volumes of cylinders or cones to give us the whole volume. So let's consider this example. So we've got the following sketch. We've got a curve, a cubic curve like this. This is y equals x cubed plus 2. And we have the line. This is the line y equals 5 minus 2x. And then we have this shaded region here. And this region is rotated around the x-axis, and we want to find the volume of the solid of revolution formed. So the blue region is rotated around the x-axis by 360 degrees. Find the volume of the shape formed. So we can split up this region. We can split it up along this red dashed line. So on one side, we've got a shape we know how to deal with. On the left, if I call this something like R1 and R2, and if I let V1 and V2 be the corresponding volumes of revolution, V1 is just given by the formula. It's the integral of pi times the integral of y squared dx between 0 and whatever this x value is. So note that this x value here is the x value that makes 5 minus 2x 0, so that's 5 over 2. The x value here, where x cubed plus 2 equals, so to find this, we'll set x cubed plus 2 equal to 5 minus 2x, and we'll get x cubed plus 2x minus 3. And then if we think about using the factor theorem, we can see 1 is clearly solution. 1 cubed plus 2 times 1 minus 3 is 0. So x minus 1 is a factor. And then we've got another factor, which is in order to make no x squared, we need a plus x. And then we need a plus 3. Note that this doesn't give us any solutions. So the only possibility is that x is 1. So this x value here is 1. So the limits for this integral are x goes from 0 to 1. And then y squared is x cubed plus 2 squared. And then x cubed plus 2 squared is x to the 6 plus 4x cubed plus 4. And then this is just year 1 integration. So it's easy to see we obtain this. And then if we stick in the limits, we're going to get 1/7 plus 5, which is 36/7 pi. Okay, and then this second volume formed by rotating this line, this part of this line around the x-axis forms a cone. So the V2 is a cone that looks kind of like this, where it's formed by this line y equals 5 minus 2x. So you can do this again by integration, but we don't need to. It's probably quicker just to do the volume of the cone. Because what is the radius of the cone? Well, it's whatever the y-coordinate of this point here is. So we know the x-coordinate is 1, the y-coordinate is 3. So the radius of the cone, this radius here, is 3. And the height of the cone, this height here, is the distance between 1 and 5/2, which is 3/2. That's the height. So V2, which is the volume of a cone, is pi times the radius squared times the height, which is 27/2 pi. And, oh, sorry, a third pi, isn't it? So no, it's 9/2. And yeah, so then in order to find the total volume, we just need to add the two volumes together. So therefore the volume is V1 plus V2, which gives us 135/14 pi. Okay, and we'll just do a second example. So if we consider the region given in this diagram, so if I draw in different colors, we've got a curve like this, not quite like that. This is y equals root x, and then in red we'll have this curve here. It shouldn't touch the x-axis there, but it's approaching it. It's y equals 1/8x. And then we have a line here at 1, and then this green region here is the region to be rotated. So we can just say the green region is rotated 2 pi radians about the x-axis, and the question again is find the volume of the solid generated. Let's say find the exact volume. Okay, so the solution, well, firstly, it would help immensely if we knew what this point here is, what the x-coordinate is. So we can first we can say at this point of intersection, at the point of intersection, which equation is true? Well, we must have root x equals 1/8x. So this is equivalent to 8x to the 3/2, because x root x is x to the 3/2 equals 1, or x to the 3/2 is an eighth. So therefore x is 1/8 to the power 2/3, because if we raise both sides to the power 2/3, it will get rid of the power 3/2. And then this is a half squared, which is a quarter. So this x value here is 1/4. And again, we want to split up the volume somehow in a way that would be sensible. So one thing we can do is notice that under this blue curve, if we split up the blue curve between 1/4 and 1, like this, and then rotate this region, and then if we do the same thing under the red curve and rotate that region, and then subtract them, that will give us the volume of the green shape rotated. So let's first find the blue volume, which I'll call VB. So this is going to be the integral between 1/4 and 1 of, again, pi y squared dx. Notice this is part of a paraboloid. Well, the surface formed is part of a paraboloid, because y equals root x is a parabola. So, or, well, half of a parabola. So this is pi x dx, because root x squared is dx. So this is pi x squared over 2 between 1/4 and 1, which is 1/2 pi minus pi over 32, which is 15 pi over 32. And then the red, so now this red region here, we're going to rotate that around the x-axis. So VR, the red region, is again integral from 1/4 to 1 of pi times y squared, which is 1 over 64x squared dx. And once again, we do year 1 integration, and the integral of x to the minus 2 is minus x to the minus 1. So we get minus pi over 64x between 1/4 and 1. If we put in 1, we get minus pi over 64. If we put in 1/4, we get plus pi over 16. So we're going to get 3 pi over 64. And now, the volume of the green region rotated, we just need to subtract these two. So therefore, total volume is going to be 15 pi over 32 minus 3 pi over 64, which is 27 pi over 64.